All right, everybody. So welcome back to another My PTA video. As you can see on the screen here, I've basically drawn out this little picture here. These are all basically different nuclei. It's a collection of nuclei within the basal ganglia region of our brain. So I'm going to be going over the direct pathway today. So as you can see in the top left corner, there's the motor cortex. And basically what that's doing is it's releasing glutamate, which excites that striatum. So then the excited striatum is sending inhibitory signals to the globus pallidus internal, which you can see there in the bottom right. So it does that through GABA. That's basically a calm down chemical, which basically relaxes the globus pallidus internal. So it inhibits it. It doesn't relax it, but it inhibits it. And then that basically releases the hold on the thalamus. So when our thalamus is more active, we have more movement. So the way that it was explained to me in class was that the thalamus, think of it as like this puppy who just wants to run and be crazy and be free outside. So the thalamus is that puppy. And if the globus pallidus internal does not get those inhibitory signals, it's going to really pull back on that thalamus, keeping it from being overly excited and everything, keeping it from running away and just going crazy. So by the striatum receiving that message from the motor cortex through glutamate, it's sending inhibitory signals to the GPI, which then basically it's increasing the inhibitory signal. So it's inhibiting inhibition. So the global pallidus internal wants to pull back. It wants to keep the puppy in line. But by the striatum releasing that GABA, it basically kind of lets go of the leash a little bit. So the thalamus, the puppy in this scenario, is able to run just wild and crazy, and it's excited. And because it's excited, the motor cortex gets excited, and motor being movement, that creates more activity, more movement, because the thalamus is excited. The leash has been let go. So as you can see down in the bottom left, actually, I have the substantia nigra, which is a portion of the brain that becomes deficient with dopamine in those who have Parkinson's. So that's where dopamine is released. So if that area of the brain is inefficient in releasing the dopamine, it can basically inhibit our movement. That's why they sometimes get tremors or they can't start doing movements, because they don't have that really active thalamus allowing the motor cortex to send those movement signals. But in an active person, when you release dopamine from the substantia nigra, it locks onto that D1 receptor, which increases even more inhibitory signals, which sounds like it would inhibit, obviously. But once again, you're inhibiting the inhibition. So by increasing dopamine and increasing that inhibitory signal, you're just letting the leash go. It's just gone. So the thalamus is just running crazy, running all over the lawn, getting in the grass, digging up dirt. It's just being crazy. It's a crazy puppy. No leash, no rules. So I hope this quick little video was maybe just a little bit more insight as to how the system kind of works. And I don't know if I said it in the beginning of the video, but this is the direct pathway. So I'm actually going to have another video talking about the indirect pathway. But I hope you liked it. Hope you learned something. Let me know what you think down in the comments below.